Yeah, I like this. Let's do that one first. If x goes to infinity, what happens? Well, this is all infinity, right? So this is the square root of infinity minus x. What? How in the world are we going to do this? Because this does turn out to be like infinity minus infinity, and isn't that an indeterminate form? Right? What's that? Isn't this a little more than this? Yeah, I mean, you could argue that. We need to show it. We need to somehow show that that left side is going to overwhelm the right side. If it is, we need to show it. We don't need a ln because the x doesn't appear both in the base and the exponent. All right, so how about, there's a couple of different ways you could do this, but how about this one? Let me see if this one. Tell me when you know what I'm going to do. Ah, there we go. I'm going to do the conjugate. To get rid of the root, and not only that, look at this conjugate. When I put this conjugate in here, the conjugate does not have the problem of infinity minus infinity. It's infinity plus infinity. So that would be infinity. But it should help me, hopefully, this may not work, it should help me. Let's multiply this out up top. This is the limit as x goes to infinity. Okay, so here to here, here to here, here to here, here to here. So when we multiply the roots together, the roots go away. X squared plus x. Middle terms, gone. Last term, minus x squared. Yeah? This is all over the conjugate. Root x squared plus x plus x. And the top just becomes x, doesn't it? Crap. All right. Can I cancel these? So now what does our limit look like now? Infinity over infinity this time. L'Hopital. L'Hopital, right? So if you're sitting there saying, gosh, for these problems, I have to be able to recall all this stuff from algebra and like be able to do limits that might have L'Hopital. Like, yes. I mean, this is what makes these such great problems, is that they really bring the whole thing together. They force you to be able to do everything that we've basically been doing, right? And this, imagine if I change the problem just a little bit, I mean, just how everything else changes, right? The limits may be completely different. How do you handle those? The asymptotes might be different. You might have verticals, so. Yeah, okay, here we go. L'Hopital. Derivative of the top, that's a nice one, right? 1, yay. Derivative of the bottom. Okay, what's the derivative of this? 1 over 2 root of all that times the derivative of what's in there, 2x plus 1. So I'm going to write it like this. 2x plus 1 over root of x squared plus x. And then plus the derivative of that, so plus 1. Yeah? Did that help? Let x go to infinity again. Infinity over infinity again. Not only that, doesn't this actually look a little worse than what we started with? I don't know. Should we not continue? What do y'all want to do? I don't feel like doing L'Hopital again. What I'm saying is we could just take this over to the side as its own problem and do that limit and do L'Hopital again. But I have a feeling that it's not going to get any nicer. It's going to keep on spitting out the same thing. When I do the derivative of the bottom, I'm still going to get the same thing every time, right? So maybe not. Okay. What else can we do? This is good. This is good. I picked a good problem. This is right out of the book, okay? Just so you know, I'm not like, this is number 20 in this book. There are 42 problems. No, there are 44 problems in this section for graphing. I've picked number 20. So right in the middle of the section of homework, this is what they're asking you to do. All right, so I'm a little bit jammed up here, so I'm going to start over. I like the fact that that didn't work. Okay, watch this. You ready? Watch this. Limit x goes to infinity, square root x squared 1 plus 1 over x minus x. Okay, what did I just do? I factored an x squared out of this. So I pulled an x squared out of that, which left me a 1. This didn't have an x squared, right? But I can pull an x squared out, and it would become 1 over x. Just double check that you understand that. If I multiply x squared back in here, the x squared over the x becomes an x, right? So is that a legal move? Why am I doing this? Why did I do that? Why do I like having an x squared here multiplied under a square root? What is this really going to be? That x squared can actually come out as a what? As an x, which would match this, wouldn't it? And then I could GCF it. Watch. So I'm trying to get you to understand why I did that. I pulled an x squared out so I could do this on the next line. See that? And now these both have x, don't they? Yeah. So pull that x out. And then that would leave you with the root minus what? 1. Now, let x go to infinity. You'll have infinity times 1 over infinity is 0, plus 1 is 1, root 1, 1 minus 1. Shit, infinity times 0. We thought we were there. We thought we were there. Because we get infinity times 0. It'd be nice if that was infinity times 1, right? Yeah. Oh. Okay, so we have infinity times 0. So what can we do when we have infinity times 0? Take one of them and drop them. Okay, so I'm going to take the x and drop it. What a great problem. Man, I like this one. So here's where I am. I'm going to take root 1 plus 1 over x minus 1, leave that up top, right? And then I'm going to take the x that's here and drop it to the bottom as a 1 over x. Now the reason I'm really happy to see this is because I know that when I take the derivative of 1 over x, I'm going to get negative 1 over x squared. And I'm going to do that up here too. When I do this derivative here, I'm going to have that chain rule happening. And I'm going to take derivative 1 over x in here also. So I'm going to have that same thing pop out of both. You'll see as we move through it. But I'm actually encouraged right now. OK, L'Hopital now. Derivative of the top. So what is derivative of the top? Well, derivative of root of something is 1 over 2 roots of that something. Looking bad right now. Times the derivative of what's in here. X squared. So negative 1 over x squared. I really hope by now, coming out, doing this enough, that you know that the derivative of 1 over x is negative 1 over x squared. Because we've done it, I think, enough times. I hope we have. I hope you have. OK, is this the derivative of the top? Yes. Take derivative of negative 1 is 0, right? OK, all of that over the bottom, derivative of the bottom is negative 1 over x squared. And these cancel. And I am now happy. So Hugo, do you see what's going to happen? When we let x go to infinity, we get 0. This is 1. Root 1 is 1. 2 times 1 is 2. 1/2. So what I'm saying, Hugo, is that it looked like it in the beginning, like that root part was going to dominate the minus x. It actually doesn't. They actually, they're both very strong terms, and they kind of battle, and they compromise at 1/2. So when we graph this and you go out to the right forever, it's going to be going towards a y value of 1/2. We have a horizontal asymptote out the right side of 1/2.
So now we got to do negative.
Now we got to go negative infinity. So let's see how the negative infinity changes things, because the negative infinity could have a pretty dramatic impact on the limit. That good? Yeah. That's messy, huh? I was explaining to my 8-year-old daughter the other day the phrase don't kill the messenger. You know? She understood it. She got it. She's like, yeah, you don't get mad at, you don't kill the person who's giving you the bad news. I always feel like I'm the messenger. I'm sorry. Like, this is the subject. This is the material. We are at a point where it's bringing everything together now. So yeah, this looks pretty, daunting, but it is what it is, right? I can't sugarcoat it. I guess I could just give you a parabola and ask you to graph that, but I don't think that really prepares you to become an engineer by giving you some easy problem to think about. You have to be able to think critically. So, all right. We're going to do the same limit. We're going to negative infinity. This might be nasty. Let's see. What, x squared plus x minus x? All right, when we go to negative infinity, I think what I'm going to do first is make sure inside this root, I'm just going to pull an x, not an x squared. Just pull an x real quick, because I want to see what happens on the inside. So what happens when we go to negative infinity? This is a negative number, and this is a negative number. And two negatives multiply to be positive. So we can take the root of that. So it's OK. And then I'm going to subtract negative infinity, which is meaning what? Add? Ooh. This is actually good. OK, so look. This is going to negative. Let's do it like visually. This is negative infinity times negative infinity, which is the root of infinity, which is infinity, right? That's what's happening here. And then this is minus negative infinity, which is really plus infinity. So this is really plus infinity. So this is infinity plus infinity. That's infinity. It's not minus. So this is good. No work. It's infinite. So the left side, going out the left side, just goes up. Right? Goes up to infinity. OK. Clear? All right, let's keep going. Man, I only have 8 minutes. All right, we need derivatives, don't we? We need derivatives. For the next parts, we have to do the first and second derivatives, don't we? So just because I only have 8 minutes, let me take the first and second derivatives. Just let's get those out of the way. All right, the first derivative of this function is, all right, derivative of root of something is 1 over 2 times root of that something times the derivative of what's in there, which is 2x plus 1, and then minus the derivative of x, which is 1. So there's your first derivative. If we clean this up a little bit, we get 2x plus 1 over 2 roots of x squared plus x, and then minus 1. So that's my first derivative, right? Yes? OK. Second derivative. Let's go ahead and get that out of the way now. Second derivative. I need to take derivative of this. So that part's done, right? That's 0. Who cares? This is quotient rule. Right? Quotient rule. So derivative of the top times the bottom minus the derivative of the bottom. Ooh. So the 2's out there for the ride. This is the 2. Derivative of the root of something is 1 over 2 roots of that something times the derivative of what's in here, 2x plus 1 again, but then times what? The 2x plus 1 again. All right, that's just the top. That's all over the bottom squared. So 2 root x squared plus x squared. That looks bad, doesn't it? And we have to set that to 0. It looks worse than it is. No, that's bad. Okay, all right. Let me go back to the first derivative. We have to set this to 0, don't we? If I'm going to set this equal to 0, then I'm going to get a common denominator. So I'm going to do that now with that in mind. I'm going to do 2x plus 1 over 2 root x squared plus x minus 2 root x squared plus x over 2 root x squared plus x. See how I'm just turning that negative 1 into this right here? So we have same denominator. And now let's put them together. So that's 2x plus 1 minus 2 root x squared plus x over 2 root x squared plus x. Cancel, can't cancel anything because there's multiple terms in the top. I almost wanted to cancel a 2, but that doesn't have a 2. So that's it. That's your first derivative with a common denominator. If I set that to 0, what do I have to do? Just set the numerator to 0. What type of equation is that? Radical equation. How do you solve a radical equation? You isolate the radical. You square both sides. It's going to become a quadratic, and then you're going to have to solve a quadratic equation. Yay. Okay.
All that in 4 minutes.
Understand? This will be your homework. That'll be turned in at the beginning of the next class. Treat it like a test problem. Okay, let's clean this one up. Let's clean this one up. Let's see here. This is 4 root x squared plus x. And then these two's canceled. So we have minus 2x plus 1. There were 2 of those factors over the root of x squared plus x over 4 root, well, should I square the bottom now? I'll square it, okay. So what I did here was I just squared the 2 and squared the root, which made it a 4, and then the root went away, right? Are y'all comfortable with what I did up on top? This squared over that root, 2's are gone. See if you follow my next line. 4 x squared plus x minus 2x plus 1 squared over root x squared plus x over 4 x squared plus x. Can you tell what I did there? I got a common denominator. And to do that, I had to look at this as being over 1, right? And then I introduced this root, x squared plus x, root x squared plus x, on the top and bottom of this fraction. And when I put it on the top, they were the same root, so the root went away. And then I put it on the bottom, well, then I have my common denominator. So that's why I have this right here. This is that numerator. The 4 was up there, and then the root went away. Then I have minus this numerator squared over the common denominator. One more line. This over 1, right? Fraction over fraction, flip. So this is going to go away. And down here, I'm going to get the 4 and then the x squared plus x down there with it, right? So at the end of the day, that second derivative looks like this. It is 4 times x squared plus x minus 2x plus 1 squared over 4 x squared plus x to the 3 halves. What did I do there? This right here, x squared plus x, that's to the first power, right? And this right here, x squared plus x square root, really means to the 1/2 power. So if I have something to the half and something to the first, you add the exponents, and 1 plus a half is 3 halves. So I put these two together into this. That's your second derivative. Here's your first derivative. All right, so for homework, what I'd like for you to do is see if you can't finish this out.
All the way to the graph?
All the way to the graph. Just keep in mind, when you have to set this equal to 0, right? I said you're going to have a root equation, so you have to isolate the root, square both sides, right? What about when you look at the derivative, where is it undefined? Well, that would be wherever this is 0, right? We already know where that happens, at 0, -1. Because remember when we were trying to find the domain of this, we said that this would be 0 at 0, -1? So those would be critical numbers, 0, -1. However, those are the endpoints of your domain. So when you draw your number line for the first derivative and you go like -1 and 0 are critical numbers, you don't have to do anything in the middle because that's not part of your original domain. Same with this over here. This is still a square root. So 0, -1 will still be here. You'll want them on your number line, but you won't want in between them. Let's just see how this goes, all right? So on a separate sheet of paper, you can just take it from this point on. You don't have to redo everything else. And let's turn that in, beginning of class. You can help each other with it. You can get tutoring, but just don't go in there and be like, I need to have this ready next time. Do it for me. Learn something. All right, have a good rest of your day.
So, do we say just the top for second derivative? Do we say
Upon